Hi, everyone, and thank you for joining us for today's webinar, which will be an introduction to the Femap Post-Processing Toolbox. My name is Jonathan Hill. I am from ATA's Washington, D.C. office. And before I turn things over to Andy in San Diego for the feature presentation, I'd like to give just a quick intro to ATA, as well as share some basic housekeeping. So first off, we'll open things up for questions at the end of the demonstration. But until then, everyone has been muted so we don't have any background noise or disruptions. When we get to the questions, you'll be able to unmute yourself using the button in the bottom left corner. And in addition, you can submit questions publicly to the group or privately to me at any time using the chat, which you can also find along the bottom menu bar. Just note that we'll also wait to address those chat questions until the very end as well. Finally, we are recording today's presentation. It should be available in the free resources section of our website in the next few days. So keep an eye out for that if you would like to rewatch certain parts or share it with colleagues. So continuing on with a brief intro to ATA, in addition to our role as a Siemens partner and reseller, ATA is also known for our robust engineering services, and these two complement each other very well. When our software customers run into trouble, we're able to provide exemplary support by leveraging our experience overcoming similar problems across a wide range of industries and our services. On the services side of things, we offer complete integrated solutions with a focus on analysis and test-driven design, with many of us working across disciplines to find the optimal solution. So whether that's analyzing the next generation of planetary rovers or performing ground vibration tests on state-of-the-art aircraft, ATA is proud to help our customers meet their toughest engineering challenges. Of course, being experts with Siemens PLM software helps us to do precisely that. Speaking of the software, ATA can assist you with a variety of Siemens product lines, and I've listed just some of those here. That includes Femap, which we'll focus on today, as well as SimCenter Nastran, which formerly was NX Nastran, SimCenter 3D, and Start CCM Plus. And our technical support hotline is staffed by experienced engineers who are using these tools every day. In addition, we can help with license sales, and we offer a variety of classes covering everything from introductory to more advanced topics. ATA also develops the official SimCenter Nastran training material and is the preferred North American provider of SimCenter Nastran training. And Siemens has recently recognized us as a smart expert partner based on our validated expertise with Femap and Start CCM Plus. After the webinar, I would like to invite you to check out our software website. It has a schedule of upcoming classes and a contact form for our hotline, in addition to the latest software product information and brochures, as well as links to free trials. I also have to mention my favorite part of the site, which is our growing collection of free resources. You can get to those by going to our site and clicking the yellow button. And these include white papers, training videos, tutorials, APIs, and so much more. And all of these resources are developed by our own engineers, and they're specifically aimed at our customers' needs. While we're on that topic, I'd also like to say that we're always looking for suggestions. So if there's a particular topic that you would like us to consider in the future for a resource, definitely please reach out to us and let us know. With that, though, I think we are ready for our feature presentation. So Andy, the floor is yours.
Thanks, Jonathan. So thanks, everyone, for attending this Femap Post-Processing Toolbox webinar. Before I bounce over to Femap and begin the demo, I first wanted to briefly outline the topics that we'll be discussing. We'll open with a brief discussion on what the Post-Processing Toolbox is and offer some thoughts on when it might be advantageous for you to use. And then we'll proceed with highlighting some post-processing commands and view options within each of the three tools in the post-processing toolbox. And those tools include the Deform tool, the Contour tool, and the freebody tool. So with respect to the Deform tool, we'll be looking at deformed and undeformed views and animations. Related to the Contour tool, we'll take a look at different contour settings you can adjust, as well as section cuts, contour arrow displays, and dynamic criteria plotting, which is new to Femap 12. And then we'll close with taking a look at the freebody tool and learning how to create freebody displays and compute interface loads. So with that, I'm going to move over to Femap. And for this demo, I'll be looking at Femap or using Femap version 12.0.1a. And in case you forgot how to check which version of Femap you have installed, you can easily do that by going Help and then clicking About. And it'll be listed at the top right here. So as you can see, I'm using Femap version 12.0.1a. And you'll notice that when you open Femap, you should see the post-processing toolbox docked here with the model info pane and the meshing toolbox. If you happen to open Femap and do not see it, it's most likely just turned off. So you can easily turn it back on by going to Tools and then clicking Post-Processing Toolbox. And then you should see it appear. Alternatively, you can click this icon to toggle the Post-Processing Toolbox on and off. And by default, the Post-Processing Toolbox is docked with the Model Info pane and Meshing Toolbox. But you're free to drag and drop it anywhere you like on the screen. So you can simply left-click, and then you have the option to dock it in the top, bottom, right, wherever is most convenient for you. And I've heard that a lot of users do like to have it docked on the right so that they can go ahead and change group displays from the Model Info pane while adjusting contour settings over here on the right. But for this demo, I'm going to go ahead and keep it docked in its default position so I can easily just drag and drop it back here. And once again, dock it with the Model Info pane and Meshing Toolbox. So beginning with what the Post-Processing Toolbox is, I think the best definition for it is that it's really a consolidation of post-processing commands and view options that were traditionally accessible through dialog boxes. Now, that's not to say that those same commands aren't still accessible through those same dialog boxes. They are. And when I refer to the traditional dialog boxes, what I'm really referring to are the View Select and View Options dialog boxes that we're all familiar with. So we know we can access View Select by hitting the F5 key on our keyboard. And then we have the option to turn on deformed and contour shapes. Alternatively, you can get to View Select by clicking this icon at the top, or going View and then Select. And then the other type of dialog box we're all familiar with for changing contour settings is the View Options dialog box, which you can access using the F6 key on your keyboard. Or alternatively, you can pull down on this View Styled menu and get to View Options here, or click View and then Options. So if you're an experienced user of Femap, you'll likely still lean on these dialog boxes and use a combination of the post-processing toolbox and the dialog boxes. But it's really useful to know what the post-processing toolbox offers, because there are a couple of features that are available in the toolbox that aren't available in the dialog boxes. The most notable of these being the freebody plotting functionality. So with that, I'm going to start, before getting into these three tools in the toolbox, I'm going to briefly describe the model we'll be looking at today. So this is a hypothetical assembly of a spacecraft-mounted instrument, and essentially it's a box with a detector plate on the inside supported by 3 struts. And our box elements here are modeled with shell elements, as are the elements on the top of the box and the base plate. And on the inside, our detector plate is modeled with 3D solid elements, and the 3 struts supporting the detector plate are modeled with bar elements, as are these elements running along the top of the plate here. These are also bar elements. And I went ahead and threw in some coincident C bushes to attach the struts to the solid detector plate mesh. So the connection scheme goes bar element to coincident spring, and then a rigid spider on out to the solid elements. And so this model is really conducive to this webinar and this demonstration because it offers 4 different element types on which to view results. We have plate elements, solid elements, bar elements, and spring elements. So it's going to give us a good variety of elements on which to review results. And briefly discussing the loads and boundary conditions, I simply have the 4 corners of the base plate constrained, as you can see here. And then I applied 4 different load cases to get a good variety of contour results. And they're all inertial loads. So I went ahead and applied 10 Gs in X, Y, and Z separately. And then I had a 4th load case that I was calling 10 Gs off axis, and where I was applying equal magnitudes in X, Y, and Z such that their RSS added to equal 10 Gs. And you can see that resultant vector shown here. So with that brief outline of the model that we'll be looking at, I'm going to go ahead and jump over to the post-processing toolbox. And when you open the post-processing toolbox, you should see these 3 tools available to you: Deform, Contour, and Freebody. If you happen to see one or all of them missing, you can easily toggle them all on and off at once through this dropdown. So I'll just go ahead and toggle them all back on for now. And we'll begin with our Deform tool. So common to all these tools in the toolbox, they all have a style section and then a result section. So the styles section will have options unique to that specific tool you're looking at. So it should be pretty intuitive and obvious that for the Deform tool, we obviously have styles available to us such as Deform Shape and Animation. So I'm going to go ahead and click Deform right now, and you'll immediately see that my display updates to show the Deform Shape. And so the default with the toolbox is to have this auto redraw feature turned on. And so what that means is as you adjust settings within the toolbox, your model is going to update on the fly. If you would instead prefer for your model to not update immediately, and you would prefer to make several settings adjustments before the update occurs, you can easily switch this auto redraw feature off by clicking this button. And then you'll see if I switch back to undeformed shape, nothing updates until I come up here and I click manual redraw, and then I get the update. But for this demo, I'm going to go ahead and keep auto redraw on to have these settings update on the fly. And so with that back on, you can see when I pull down and turn on deformed, the setting changes immediately. So moving on down in the Deform tool here, we arrive at our results section. And so here I have the option to choose from my list of result sets. So I can click this icon and choose from a list. Or alternatively, I can just click these left and right arrows, and it'll take me to those different results that I have. So you can see I have my positive Y deformation shown here, my positive Z, and then my off axis. And the same functionality exists for output vectors. I can click this icon to choose among a list of output vectors, or I can just move these left and right arrows to scroll through my vector results. So in the Deform tool here, I also have the option to change the deformation scale that's visible. The default is % of model, which adjusts the deformation based on the length of your model. I can switch over to perhaps the more intuitive actual deformation setting, which will obviously deform and scale according to the actual deformation. So you can see there's not much of a change here. So why don't I go ahead and turn on my Contra results just to get an idea for the magnitude of my displacements. So you can see my displacements here are really small. So it's no wonder that with a deformation scale of 1, that there's nothing really discernible. So why don't I go ahead and up this to see if we can notice any change. So you can punch in whatever scaling you want here. You can go 100, 200, and we can start to see a bit of a deformation change now. And so if you'll recall earlier, I had said that these same options that are available in the post-processing toolbox are still available to you in the traditional dialog box locations. So what that also means is whether you change the setting in the toolbox or you change the setting in the dialog box, it's going to have the same effect. So I can prove that here by hitting F6 to open our view options. And if I click the post-processing radio button and then click Deform Style, you'll see that when I had updated this scale actual by to 200, that also changed the setting in the dialog box. And so here I can alternatively change this here to 100 in the dialog box. And when I click Apply, you'll see the view update, and you'll see this setting in the toolbox update as well. So there are view updated and the setting changed in the toolbox. So that's just proof that whether you adjust something in the toolbox or in the dialog box, it's going to have the same effect. So I'm going to go ahead and switch back to just % of model now for my deformation scale. And also a quick reminder is while you have a contour displayed here, you can really leverage these view style options to quickly say turn on and off thicknesses and filled edges. And you can easily adjust your display with contour results in view. So I just wanted to remind everyone of that convenient feature here. So moving on down, you can also turn on and off the undeformed shape, or the undeformed model rather. You can change the color of that undeformed model. I have the default here set to gray, but I can change it to yellow or whatever color I choose. And so that really captures everything I wanted to discuss with respect to the deformed and undeformed views within the Deform tool. So next I'll go ahead and move to animations. So if I pull down on Style and select Animate, you can see the model immediately goes into an animation. And in addition, this animation option was made available to me. So what that means is depending on the style you choose, different options are going to be made available to you within the toolbox. Because if I switch back to Deformed, you'll see that animation option goes away. So if you want a nice list of the options that are available to you, depending on the style you select, you can click the in context help or the F1 key on your keyboard, and you can see my Deform tool help immediately comes up. And if you scroll down here, there's a nice table that shows, depending on the style you had selected, the options that will appear. So you can see for these animation options, they're only really displayed when I have the animate style selected. And if you keep scrolling down in the help here, you'll see a good write-up for each of these options. So if you're ever confused at what any of these myriad of options are to you, you can easily open up the in-context help and get a good description of what all those options are. So I'd highly encourage you to explore the help because it's very well written. So moving back here, if I expand on animation, I can slow down the animation here by adjusting the number of frames, say, either by punching in a number or moving these arrow keys up and down. I can also do the same for delay to either slow or speed the animation. And if adjusting the speed of the animation is non-intuitive for you with either adjusting the frames or the delay, you can click this animation control button, which will open this much more intuitive dialog box where you can easily slow or speed the animation simply by clicking slower or faster. And it'll adjust the delay settings for you. And in addition, you can click this pause button and go move frame by frame through the animation. And so this should allow you to take really nice, convenient screenshots for reports, for instance. And the last thing I wanted to mention with respect to animations is how to make a GIF, because that's a question we often get from customers. So the most important thing to know with that is that in order to make a GIF, your animation first has to be running. So with the animation running here, I can go File, and then click Picture, and Save. And by default, it will want you to save it as a bitmap, but you'll want to pull down here and choose GIF. And I can just give it a name here. Let's call it Animation. And click Save and give that a minute to save. And I notice over here on my other screen that it has saved, so I can open that, and there's my animation. And as a reminder of how you can easily drop this into PowerPoint, if I open PowerPoint, I can simply drag and drop that GIF onto my slide, and then when I move into presentation mode, the animation is viewable. And another quick reminder about dropping images and animations into PowerPoint is that we often use snipping tools to capture the view we have in Femap. Alternatively, you can left click on your screen and just hit Control-C. And then if you come over to PowerPoint and hit Control-V, then the current view you have displayed is copied into PowerPoint. So I think that's also a really neat tip to mention, so you don't always have to fumble with the snipping tools that we all use. You can instead just do a simple Control-C, Control-V, and get your image into PowerPoint. So back to Femap now. That covers everything I wanted to discuss with respect to the Deform tool. So I'm going to just go ahead and turn off my Deform shape and proceed to the Contour tool. So I'm going to first go switch my output vector. Just like with the Deform tool, we have style and results options available to us. I'm going to go ahead now in my results section and switch to solid von Mises stress. And you'll see when I do that, the only contour I have displayed here are for elements, well, my solid elements basically, because obviously in requesting solid von Mises stress, I'm only going to see stress results on the solid elements of my model. And all the other elements I have visible right now default to the coloring scheme that I had specified, which in this case is color by property. So I'm going to go ahead and switch to color by element. And so when you see this display, the obvious question that arises is, can I plot both solid and plate element stresses at the same time? And the answer is yes. You can easily do that by clicking this checkbox next to additional vectors. And it'll give you the option to choose up to 2 additional output vectors to plot. So you can plot a total of 3 output vectors at the same time on a contour plot. So I'm going to go ahead and click here and choose plate top von Mises stress. And you can immediately see that my view updates, and now I have both solid von Mises stress and plate top von Mises stress results displayed. And so now the next obvious question you might ask is, okay, I have plate top von Mises plotted. Can I also plot plate bottom von Mises at the same time? And the answer is yes. You can easily do that by clicking this double-sided planar checkbox. And then Femap is smart enough to recognize that with plate top von Mises plotted, it would know to go and grab the same stress component on the opposite side, so that being plate bottom von Mises. So if I instead first chosen plate top X normal stress, it would know to grab plate bottom X normal stress, as you can see here. So it's pretty robust in knowing the other side of the plate component stress that you want to plot. But I'm going to switch back to plate top von Mises stress. And if for some reason you were looking at this and scanning between top and bottom, you weren't quite convinced that it was plotting both top and bottom stresses at the same time, because as you can see here, the contour looks quite similar between the two sides. A friendly reminder of how to easily query or toggle results is there's two different ways to do it. You can pull down here on the selector entity and select element, and then pull down here on selector mode and choose show tooltips. And then you can easily toggle results with the tooltips just by highlighting elements. And this little message window will appear that in fact shows results for both top and bottom von Mises. If I instead had this checkbox off and toggled, you'd see how I would only get the plate top results. So that's confirmation that we are looking at both top and bottom von Mises stress at the same time here. And then another reminder about how to easily query results is to go list, output query, and it'll ask you to choose from among your result sets, and it'll ask you to choose some output vectors that you want to query. So I'm going to go ahead and choose plate top and bottom von Mises stress. There's plate top and there's plate bottom, and click OK. And then I can just march around here and click elements, and those top and bottom von Mises stress results will be printed here to the messages window. And I can verify that between my tooltips and my querying, I get the same results. There you can see my 201 and 298 matching up, and my 187 and 62 matching up. So that was just a little aside and reminder of how to easily query and toggle results. I'm going to go ahead and turn off tooltips now and move back over to the toolbox. So another thing you can do here is if I did not want to show results on everything I have displayed here at once, I can adjust the show on group setting. So instead of showing full model visible groups, I can pull down here and I can choose a specific group to say only show results for a set of elements while having the full model displayed. So this is a really convenient thing for picture taking for reports. Alternatively, instead of pulling down here and doing it off a group, I could have said to only show results on my active group, but I could come over here and change which groups I have active and basically accomplish the same thing. So there's multiple ways to go about it. And then if I expand on levels here, I can change the coloring of my legend. We all know when we first plot in Femap, the default is to have magenta coloring. So you can click on this icon and you can select no magenta if you don't wish to have the magenta coloring. And then what I do when I do that is I often find that the default base color or dark blue is a little bit too dark for me, because when you show this in some conference rooms on the TV screens, it often comes out looking almost black. So I can come in here and choose that palette color and change it to a softer blue. And you're free to basically change any of those colors however you want. And if you want to change your default in Femap to be no magenta, and so anytime you plot a contour for magenta colors to not appear, you can easily do that by going File and then Preferences. And then if you click on Views, you can come over here to Contour Palette and pull down and click No Magenta. And if you do that, then that ensures that every time you make a contour plot in Femap, no magenta colors will appear. So I can also, from here, I can change the number of levels that appear in my legend. I can punch in a number, or I can move this slider bar. 60 is a little bit extreme, so why don't I go ahead and bring that back down to 12. I can also switch between level or banded for my legend, or continuous colors. So if I check this continuous colors checkbox, you'll see this updates to have these different levels be blended together. New to Femap 12, I can also left click on my legend and easily increase or decrease the levels just directly by clicking on the display, and I can switch between continuous and level or banded for my contour. Another thing I wanted to mention here is the default here is set to automatic. So this basically maximum level of your contour will update based on the elements and the view settings you have displayed here. But I can switch to say like max threshold. And this is a really convenient thing to do if, say, you're plotting stress results and you know you have an allowable stress that you're trying to meet. I can come in here to maximum level and, I don't know, I'll randomly choose a stress allowable of 40 psi. And then my legend will update such that everything exceeding that maximum level I specified is shown in red. So like I said, this is really convenient in a case where you're plotting stress results and you have an allowable. You can switch over here to max threshold and punch in what that allowable is, and that'll ensure that everything appearing in red is exceeding that allowable that you specified. But I'm going to switch back to automatic for now. And I can also go ahead and label, my max and min stresses that are appearing here. So by changing the max and min, it shows me what those max and min stress values are, which agree with my contour here and where they are. I could alternatively just show max only and so on. If I pull down on legend here, I can change the default position of the legend. The default is the center right. I can move it over to the left side of the screen instead. I can also choose to change the color of the labels to be either the contour colors or basically whatever color I specify. I have it defaulted to black here, but you can change amongst the palette of colors. I can also turn on basically scientific notation, and there's a myriad of other options you can adjust here, such as the sig figs and so on. But I think that gives you a nice sampling of the different contour options available to you. So with that, I'm going to proceed with a brief discussion on section cuts. So if I pull down on style here, I'm going to go ahead and choose section cut. And you'll notice that my model becomes, well, basically invisible. I can no longer see it. And what that likely means is that my cut plane is not set, such that it's not set basically on top of my model. So if I click this button to adjust my cut plane, I'm going to go ahead and define a cut plane in the global XZ. So I'm going to switch over to my global coordinate system and make a cut in the XZ plane and click OK. And so what you'll see here is that I'm only seeing results on my solid elements. And so that's an important distinction to make between section cut and, say, clipping plane, is that section cut will only show solid elements on which you have results, and it'll hide all your plate elements. And so section cut's really intended for looking at those through the thickness stress results on your solids. And I can open up dynamic control here by clicking on this button, and it brings up this convenient feature here where I can drag this left and right to adjust my cut plane, and you can easily look at those through the thickness stress results. So alternatively, if I had not used section cut and I instead turned on clipping plane, you can see that my plate results are visible, but in terms of my solid elements, I don't really get those through the thickness stress results. I only get this outer perimeter display of my solid elements. So that's the important distinction to capture here, is the difference between clipping plane and section cut, and how section cut is really intended for looking at solid element results. So next I wanted to discuss Contra Arrows. So I'm going to go ahead and switch over to Contra Arrow. And for this, I wanted to speak about contour arrows in the context of C-bush forces. So I'm going to go ahead and turn on my C-bushes. And why don't I change my element coloring from color by element to color by property so we can see my C-bushes. And I'm going to go ahead and switch from solid mimesis to bush X-force. And so when I do that, you'll notice that I had just selected bush X-force, but I went ahead and also grabbed bush Y and bush Z-force. So what that means is, based on your first selection, Femap's essentially making a guess at like the 2 additional output vectors to plot. And so if you decided that you only wanted to look at bush X and you didn't want to grab bush Y or Z, you could easily uncheck this box, and basically among these 3, you can decide what you want to display. I'm going to go ahead and display all 3 right now. But Femap is also smart enough that if I had not selected bush X force, if I had, say, selected bush Y force, it would know to grab bush X and bush Z, as you can see here. And similarly, if I had gone to the moments, and said my first selection was bush Z moment, it would be smart enough to know to also grab bush Y and bush X moment. So you can see it's pretty smart with its guessing, but this is just a friendly reminder that your first selection does matter with the other two components that it chooses to select. And then when I'm doing contour arrow plotting, I like to adjust the default settings. So if you come down here next to arrowhead and color and uncheck auto, you have additional options made available to you. And I like to change from the default double-ended arrowhead to single arrowhead. And I like to change my location to be at the tail. And then instead of using the default red, green, blue colors, I like to turn on my contour colors, also turn on contour arrows, and I also like to scale by magnitude. And so after adjusting all those settings, you can see how you get a really nice picture for a report that easily shows my X, Y, and Z forces for all my C bushes and clearly shows what my peak magnitudes are. And you can see that my peak among these is my axial Z force here on this spring. And so this is like a nice, basically demo for how to make really good bolted joint interface pictures and get a good understanding for what interface forces are per se, as a lot of us like to model bolted joints using coincident springs. So I really wanted to demo this as a real nice, convenient way to get those bolted joint force results out and into reports, say. So with that, I wanted to go ahead and move over to discussing dynamic criteria plotting. So I'm going to go ahead and pull down on style and choose criteria. And for this, I'm going to go ahead and turn on my detector plate. And why don't I go ahead and switch over to solid on Mises stress for this. So the most important thing to mention with respect to criteria plotting is it's all dependent on this limit modes you select and whether you're choosing to plot elements that pass or fail that certain criteria that you specify. So I'm going to go ahead and pull down on my limits mode and choose below minimum. And then I'm going to tell it to plot elements that pass a certain, that are below a certain minimum value that I specify. So the obvious example here would be to be plotting elements that are below a certain stress allowable. So I'm going to go ahead and type in my 40 psi stress allowable here. And I want to expand on this and turn on off labels so we can get a clear view. And so you'll see here that I'm only having a few of my detector plate elements shown. And so what that means is that it's only plotting elements here, since I said only plot elements that pass, it's only plotting elements that are below this minimum value I specified. So what's viewed here are elements that are below 40 psi, since I'm plotting stress results here. And if you click on this dynamic control icon, it'll allow you to bring up this slider bar, and you can easily drag this left and right, and you'll see the elements become basically visible and then invisible again. And so I'm basically adjusting that threshold value, and elements are appearing and disappearing based on their stress value and whether they're below that value I'm specifying. And so this not only makes for a really cool demo because it's very visual and fun to look at, but it's also really convenient, say, if you're considering different materials for this plate. If I had first started with my 40 psi, or my material that had a 40 psi allowable, and say I noticed that a large portion of my plate was failing, I could come in here and I could slide that on up and say consider instead a plate with or a material with a 60 psi allowable, and you can see a lot more elements are passing, so that might be a good design move to make. And so it's a real good way of basically seeing the hot spots in your plate and how steep those gradients are as you just simply move this slider bar left and right. So with that, that covers everything I wanted to talk about with respect to the contour tool. So I'm going to go ahead now and turn off my contour display and move to free bodies. So for this, let me change my display group real quick. And the first thing I wanted to talk about with respect to free bodies is that you can display multiple free bodies at once with different settings. So I'll quickly demonstrate that here by quickly making 2 free bodies. So you can create a free body by clicking this button, and it will take you to the free body manager, and then you can click new free body. And I'll just call this free body 1, for instance. And click OK. And then I'll come in here and choose some elements on which to display free body results for. So let's select this corner up here and click OK. And then I'll choose Show Visible Free Bodies. And then you can see I have some grid point force results shown there. And then I'll go ahead and create another free body. Just call it free body 2. And I'll choose some elements here for free body 2 to select this bottom corner and hit OK. And then for free body 2, why don't I go ahead and change the coordinate system with which those results are plotted with respect to. So I can change this to say coordinate system 12, and you can see those updated. So that's just a simple proof to show that it is possible to display multiple free bodies at once on the same plot and have those free bodies have different settings essentially. But I'm going to go ahead and delete this second free body for now and just focus on display settings for my first free body. And let me just turn off this element select for now. And so one thing I failed to mention before I started showing free body results is that in order to show free body results in Femap, you had to have requested force balance at the time of your solve. And I did that here. If I expand on analysis and bring up my analysis set manager, if we look at this analysis set and look at my output requests, you'll see that I in fact did request force balance. So this will give me grid point force results, and that'll ensure that I will be able to view free body results in Femap. So if I move back over to the free body tool, so you'll notice when I made those first 2 free bodies, I just did that simply by selecting elements in my screen, which is a completely valid way to go about it. Alternatively, I could have pulled down here and done group select. And then among my groups, I could have asked it to display free body results for different groups. So that's another way to go about it. But I'm going to switch back to entity select here and just focus on my detector plate again. And just select those elements of the detector plate. And so you can see the display here can get quite cluttered quite fast. So what I often like to do is uncheck the show visible free bodies and then update my free body settings and then turn that on as the last step so my display doesn't get so cluttered and it slows down my zooming and panning options. So I'll turn that back on here and just zoom in using F7 and then click Control G on my keyboard to regenerate the view. So you can kind of start to see our free body display here. So there we go. So you can see by default it's plotting my X, Y, and Z grid point forces. But I can expand on nodal vectors and choose to only plot my X force results or only plot Z or whatever combination thereof. I can also pull down here and choose to plot the resultant instead of those individual components. And I can also plot moment results at the same time. Since these are solid elements, it really does no good to turn that on because, as we know, solid elements do not support rotational degrees of freedom. But if I was instead plotting plate forces, or I had plate elements in view here, I would be able to plot both force and moment results at the same time. So moving on down, I can expand on view properties here, and I can change the display of these vectors. I can turn on and have them be solid arrow. I could have a red, green, blue coloring, or I could change to basically whatever view color I want. I can also change the scale factor and so on. So we're just kind of having fun and showing off some settings here, but this is just a reminder that there's multiple settings you can change to change both the scale and the coloring of these arrows. So with that, I next wanted to talk about how to compute an interface load. So for that, I'm going to, under display mode here, I'm going to click the interface load radio button. And I want to turn on the sides of my box for this. Let me go back over to my groups here and turn on my box. So say I wanted to compute the interface load at the top of the box here. So the difference between free body and interface load is that in the case of free body, it was only asking me for elements to select. When I move over to interface load, it wants me to select both elements and nodes in which to compute the summed total force result, or my interface load. So I'm going to go ahead and click on elements here and choose this top row of elements and just confirm that I got them all. And yep, I did. And then I'm going to click on free body nodes here and choose this top row of nodes. And I got them all. Click OK. And so by default, it's going to ask me, hey, based on all of these nodes you selected, should I go ahead and place this summed interface load at the center of the nodes you had selected? And I'm just going to go ahead and say yes, sure, why not? Because I have the option to change that later. So I'll click yes. And you can immediately see now that I have both free body results and my total summed interface load displayed. So I can come in here and I can choose to first turn off those free body results and just focus on this total summed interface load. And just like with the free body results, how I have the option to only display, say X force or Z force, I have those same options with the interface load. I can also display the resultant interface load. And I can display both force and moment results at the same time. So just as I was able to change, view settings with the free body results, I can do the same. The same settings are available to me with the interface load. So I can pull down here and change to solid arrow, and I can change the color, say to black or something, and so on. And oops, I was doing that for total force, so no wonder it didn't change. Let me do that for total moment instead. There we go. There's the change. And the last thing to comment with respect to interface loads is the location where those are reported. So changing this location will have no effect on your interface force results, but it will have an effect on your interface moment results because it's effectively serving as the point about which moments are summed. So with these moment results displayed, if I change my location now to say, I'll just change it at random to say 116, when I click OK, you'll notice that this will move and the magnitudes and the vectors will change. So I'll click OK. And you can see that that summation location moved and the vectors changed as did their magnitudes. So that's just proof that the location you specified does have an effect on those moment results that are reported because it's serving as the point about which moments are summed. So with that, that covers everything I wanted to talk about with respect to the free body tool. And that really concludes everything I wanted to discuss for this post-processing toolbox webinar. So with that, I'll go ahead and pass back to Jonathan, who will open the floor to any questions you might have.
Great, thank you so much, Andy. Let me set it so that everyone can unmute themselves. Okay, so now you're able to unmute yourselves if you have any questions. We did have a few questions come through in the chat, so we can go through those first. First, we had a couple questions from Brian. First, just asking if Femap 12.0.1a is out, and that has been released. So you can go to GTAC and you can log in with your web key and download and install that today. It should work with the same license file that you already have. You should be good to go there. There was also a question about if the toolbox is eventually going to replace some of the traditional ways to set view options. And I don't expect that that's the case. I expect that the Femap developers will leave that in so that if you want to jump over to the post-processing toolbox, you can do that. If you want to stick with the current methods that you already know, you can do that. If you want to do a mix. The Femap developers really like to just let everyone do whatever seems easiest for them. So I would expect that all of these capabilities would remain. There's also a question about GIFs, if that's the best animation file or if AVIs are better. As far as I know, Femap only animates animations as GIFs. I would need to check on that. But I've had very good experience using GIF files myself in terms of when I copy them into a presentation. It always works. You know, everyone's been in a meeting where someone's trying to show a video and the video doesn't come through, but I've always had GIFs work, and they animate well over screen shares and everything like that as well. There is also a question about the contour legend and whether that corresponds to the first output vector. While Andy was going, I was trying to play around on my end, and it did update the contour legend as I would turn different result sets on and off. So I suspect that, like, if you're showing plate stresses and beam stresses and solid stresses, that it would update just to show the min and max stress across the different element types, like that. Andy, there's a question in the chat. If you could show the GIF export again.
Sure. So why don't I switch back on to my animation? Let's see here. Turn off my free bodies. Change this. So all you have to do is, as I mentioned, the most important thing, maybe I'll turn on Contra results so it looks a little bit more intuitive. See, sorry. Anyway, the most important thing to note is that the animation has to be running, and then all you have to do is go File, Picture, and Save. And then it'll, default to bitmap, but the recommendation is to change that to GIF. And then you can give it a name. I just call it animation and click Save. And then just give it a minute to save. And then you'll see that GIF appear in whatever file directory you had specified. Does that cover the question?
Yeah, I think so. Does anyone else have any other questions? You should be able to unmute yourself if you want to ask us directly, or you can continue to type them into the chat as well. Brian also had a question about like a command finder. You mentioned that SolidWorks has that. I know NX has that, where you can start to type in like a function, and it will look up those commands for you. I don't know that. I don't think I've ever seen that in Femap. Andy, have you seen that?
Yeah, to my knowledge, Femap doesn't have a command finder. But as I mentioned before, I find the in context help really useful, because if you just pull down on help and went help topics, then you'll default to this, and you have search options available to you, and you can choose amongst the options here. But it's really convenient that with a command active, say, if you hit F1 on your keyboard, it'll take you right to that in context help. So I definitely recommend that people try that out. When I learned that feature, I found it to be really, really useful.
And then Andy, do you know, so when you export a GIF, does it take your current animation settings in terms of frames and delay and all of that?
Yeah, it will consider those current animation settings. So if you had adjusted the default delay and frame settings to either speed it up or slow it down, that should translate to the GIF that you export. And that's definitely something to be sure to test out before you take that GIF and take it to a customer presentation, for instance. But those settings should translate to the exported GIF, yes. Okay, cool. And then Ryan had a question about free body summations. He also mentioned that we can take that offline. So I'll leave that up to you if you want to cover that now or do that later. Yeah, that can get into a lot of detail, so it might be best to cover that offline with Brian. Those different free body load contributions essentially that you can check.
Cool. Well, thank you for the good questions, guys. Are there any other questions? We still have some more time. If anyone else has any questions. Cool. Well, if you come up with questions later on, definitely reach out to us. We're here for you guys. Again, like I said, I invite you to check out our software website and check out some of the resources there. Let us know if you have any suggestions for future resources that you would like to see or future webinar topics. And otherwise, just thank you all for joining and have a great afternoon. Thanks, Andy.
Thank you.
Yes, and I'll upload a copy of the presentation to our site in the next couple days. Cool. Thanks, everyone.